In section 7.2, we go back way in time to the first days of the course when you learned all the transformations. It was all the things like moving a function up, down, sideways, wall, window, and doing reflections. And all of that work with the basic ideas in chapters 1 and 2 will really pay off. Now, here's how I want to recommend you start. What you need to do is just memorize one thing for sure, and then maybe keep another one in the back of your mind. The memorize is the basic look of an exponential function. So if you had y equals 5 to the power x, anytime you have a number greater than 1, it is going to follow the shape and it cuts through a value of 1. The x-axis acts like a horizontal asymptote. When you memorize that function, really good things happen. Now here's a kind of a part B to the memorize. When you have it in a fraction form where this is a proper fraction and it's less than a value of 1, it basically goes down instead. It's called a decreasing function instead of an increasing. And again, we proved it with a table of values. That's not a bad one to memorize, but let's just focus on the 5 to the power x. With that memorized, when you know the basic shape of any exponential function, and this can be a 5, a 7, a 2 is what you will see here, it's very, very easy to apply the different shifts. So we go back to an old school one. Let's say you saw a negative in the very front. Well, that has always been to turn something upside down. It's been a reflection about the x-axis, a flip over it, and what we would see is this shape appearing. Just like when you take a parabola upside down, I always go back to that one. And when you look at it, you'd have to still be able to analyze all the different values, and some things change. So if you looked at this, and we'll just do it out loud verbally, what would be the domain? Well, it's still all real numbers, but what would be the range? Instead of being y is greater than 0, it would be y is less than 0. There still is no x-intercept because the x-axis is still acting like a horizontal asymptote, but the y-intercept, instead of being positive 1, it would be a negative 1. And so again, it's very, very easy to do it. Now, here is something that we know as well. There's a way to reflect around the y-axis, and every different function has that negative in a different spot. Here's where it would be when you're doing exponential functions. When you have 2 to the power negative x, when the negative is here as opposed to out in front as a coefficient, instead of it being in the A position, it would be in more of the B position. Well, then that is going to be where we flip across the y-axis. Now you'll see why I wrote this graph down as well. So we take our normal exponential graph, and if we turn it across the y-axis, it actually then flips to this. And again, you can get very, very tricked with thinking that it's then a fractional one. So these two actually have the same effect. Now, we move to another one that's one of my favorites. Let's say you had y equals 7 to the power x. Well, again, it follows this same general shape. The minus 2, way off to the side, well, that one was your vertical shift up and down. So what it's going to do is take this original graph and move it down 2 places, and this would be our most effective thing to do. Probably now, put down a horizontal asymptote. We didn't have to before because we always had the x-axis to guide us. And then another thing that you could do is, because this is a perfect number, normally it would go through a height of 1 for the y-intercept, and that also moves down 2. We could then quite neatly draw this graph. Now, you guys, just so you know, if ever you're asked to find the x-intercept, you get to kind of say, oh, nope, not doing it because I do not let you guys use graphic calculators. Anytime that they would come out as decimals, well, you don't have to say it. Now, the y-intercept is not a decimal. It's a perfect -1. That's easy to justify. But if this x-intercept that now exists when it didn't before is a decimal, you can't find that without technology. So you would not be responsible for it. Now, for the end of the day, what we're going to do is just skip right over letter D. That was graphing y equals e to the x, and I hope I did a good enough job on the previous lesson, just saying that's a normal exponential. The final example that we will take a look at is 9 to the power x. Now, this is where you just really have to kind of focus in on where are the different values. So when we put a 2 in brackets by the x, this is the exponential version of the horizontal shift, the wall, the window, and it goes back to the old days. It is opposite the sign, and here's what would happen. Your brain is going to try to take the exponential function, and it's going to try to move it negative, but it actually goes the opposite way. Now, you might be wondering, How could you graph this without technology so the teacher, if they were marking an assignment, could actually tell you knew what you were doing? Well, here's what you could do, and just watch as I air draw it and listen carefully. Normally, if you just had y equals 9 to the power x, it would come up through 1. Well, what will happen is everything moves over. So we could move that whole graph over, and this y-intercept that would have been through 1 would actually get shifted over. And so then the graph would look something like this. Now, we're not perfect because we don't have, again, technology, a calculator, or a computer, but you could even show your teacher that you understand the basic movement. You could show that this graph got moved 2 places over horizontally. Instead of going through 1, well, you're kind of visually showing that's where it would have been, and this is definitely then a y-intercept of less than 1, which you would not be responsible for because, again, it's a decimal value. Now, the formally written shows all of it, and there's no example to give because we've pretty much done it in the small pieces. And you rarely have to graph one that is all the way there. This would be the formally written version of all of these transformations. You could have y equals a, and then c. Don't forget c is just any number, whether it be a 9, a 7, a 5, a 2. And then we would have a b, an x minus an h, and then a plus k. Now let's just start to analyze. The k, one of my favorites. That is the one that moves things up and down, like letter C. The h, that's your wall window, your horizontal shifts, that's like the -2. Now, the a and the b, we got to take those guys with a grain of salt. If you have a negative with the a, that turns it over the x-axis, that reflection. The negative in front of the b is a y-axis reflection. If we put a number here, that was actually a vertical stretcher compression, and the putting a number here is a horizontal stretcher compression. I will, just like in the old days, make you guys acknowledge that, but not make you actually do it. Because to stretch this guy vertically, we go back to the old days, well, this goes up to positive infinity anyway. So to stretch something vertically, it doesn't, it changes it slightly, but not enough to graph it by hand.